Okay guys, let's take a look at another tutorial. So this is an important concept in Python known as dictionaries. It's a pretty unique structure. It's used to store information, and the reason we're going to use it is because we're going to make a big dictionary that has all of the values of our periodic table in it, and then we're going to be able to call it up whenever we want. But for now, let's learn the basics. So a dictionary is something that stores keys and values. So let's look at an example. Let's make a dictionary called fluorine. I'm just going to call it capital F actually. So these dictionaries always begin and end with curly braces, as such. So here, let me write that. Begin and end with curly braces. And in this dictionary, we're going to store some of the properties of fluorine. So we can start with something simple like name, and I'll just say the name is, let me spell it right, fluorine. So it always has this syntax, so it's the name of the key in quotation marks, colon, and then the value for that key. So in this case it's fluorine. It doesn't have to be text, so for example we can store the number of valence electrons, we'll call it valence, and we'll store it as the integer 7. Each line ends with a comma except for the last line. So let's make up some other attributes to it. So let's just say we're going to have a key called metal, and it's going to be true if it's a metal and false if it's a non-metal. So let's call that guy false. And I don't know, let's make up something else. Let's say atomic number. So that's going to be another key, atomic number. And so the atomic number here is 7. So that's all of the values we're going to store in this dictionary. So this is basically kind of like a dictionary in real life. It's just a little reference that we have, and we can use it to look up things. So let's look up some of the attributes. So let's look up the number of valence electrons in fluorine. So there's a couple different ways to do this. Let's start with the first way. So we'll say valence. I'll call it valence electrons, whatever, equals. So what you want to do is put the name of the dictionary. So in this case it's capital F, these two brackets, and within the brackets we're going to call valence, which is the key that we're trying to look up. So we've set this variable valence electrons equal to this value out of the dictionary. Let's print it to the screen so we can look at it. So let's print the valence electrons in fluorine. And yeah, so I'll print this here, valence electrons. So let's print that to the screen and see what we get. Python 3, dictionary, tutorial. Yeah, so the valence electrons in fluorine is 7, so it returned the value of 7 just like it was supposed to. Let's look at another way. It's pretty simple. There's this get function. So in this case, let's look up the number using this get function. I'm just going to make up a silly variable. So we'll say purple is equal to capital F dot get. Once again, this capital F is the name of our dictionary here. So capital F dot get, and then in the parentheses, valence. And let's print that to the screen as well. So the valence electrons in fluorine again, and purple. That's what we stored the variable as, remember. So purple is equal to this value out of the dictionary, and we're going to print it to the screen. Let's see what we get this time. And once again, we get 7. So that's all well and good. The really useful thing though is that we can build nested dictionaries. So we can create one large dictionary that has all of these dictionaries within it. And the reason that's useful for us is because we're going to use it to build a periodic table. So let's build a nested dictionary. So we're going to make a big dictionary called periodic table. Once again, it begins and ends with these curly braces. So let's put those there. And it's going to have dictionaries within it. So our first dictionary, let's call it hydrogen, or let's call it capital H. So we can call it capital H, and then we can put some similar attributes in it. So because this is also a dictionary, it also begins and ends with a curly brace. So let's start adding some attributes here. So our first one can be name once again. And, so name, colon, and hydrogen. And let's also put the number of valence electrons. So the number of valence electrons for hydrogen is 1. And let's leave it at that. So that's our first dictionary entry. We have to put a comma after this to let us, because this is an entry within this larger dictionary periodic table. So let's add another entry. Let's put helium. Once again, it starts and ends with curly braces. It has an attribute name called helium. Oops, I forgot the comma. And the valence electrons there are 2 of them. Okay, and that's it for our helium. And let's just add one more for the heck of it. Let's add lithium. Once again, lithium. Let's type out the full name here, lithium. And that has 3 valence electrons. Okay, that looks good for now. You can add some more later, so add more later. It's a nice reminder for ourselves. So let's run it to make sure I didn't make any typos. Let's see, it's complaining about something, invalid syntax. Okay. Oh, and that's a good point. I'm not supposed to use an equal sign. See if this fixes it. Sometimes I get messed up with the syntax, so you can always look these things up online. There's a lot of online tutorials about it. But yeah, so you can see that I'm not supposed to use an equal sign. I'm supposed to use a colon. So excuse me for that. And of course I should. It's a dictionary. Okay. Let me get rid of these equal signs and. Okay, now we're back in business. Okay, so I made this this periodic table. Let's try to call some of the values. So let's call values. So let's say helium valence, and that'll be equal to periodic table get. Let's just call helium for now, but I'll leave the name helium valence. So let's say helium. And I'll print that to the screen. So let's print helium valence. As I said, it's just going to be the value of helium for now, valence. And I'm going to get rid of some of this stuff up here just to make it look a little bit neater. So I'm going to comment out these print statements. Alright, and let's run that and see what we get. Periodic table is not defined. Interesting. Oh, it's because I typoed the spelling, so sorry about that. So periodic table. Is that spelled right now? Yeah, okay, that looks a little bit better, so hopefully it'll run this time. Okay, and it's saying none, so it's not. You know why? Because I didn't, yeah, so the value in the dictionary I'm looking for is this, so HE, so I have to call that. Sorry about that, guys. Okay, so this time it actually found it. So the value of helium valence, it's giving all of the values in the dictionary here. Okay, so let's try to get those values. So to get the values out of the nested dictionary, I can call even further arguments. So I can say, I'm going to change this to helium. So I'm just going to call this helium, and I'm going to say helium valence is equal to helium.get, and I'm going to try to get the valence states now. So what it should print to the screen is the value for helium and the valence, which in this case is 2. So let's see if it works. Yeah, and there we have it. So this is how we're going to build our periodic table, and we're going to build on our formal charge calculator.